Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So I will try to present you a very simple approach for today's problem, and it will be really simple. I will not use any inbuilt function of C++ as you will find in many of the other solutions. So let's see the problem statement as first. Although this is marked as hard, but I will definitely suggest you first try it on your own, then only continue watching the video, because this is not at all hard. I don't know why it is marked hard, but after I explain you, we will be able to understand it very clearly and easily. So you are given a 2D array queries where queries of I is in the form of L to R. So you are given Q queries, all of them from L to R, and the Q range, the range of Q is nothing but this 25. And what you need to do in one operation, you can select two integers A and B from the array and replace them with floor of A by 4 and B by 4. So L and R defines all the elements from L to R. So let's say 2 and 4, if it is given, it denotes the array is 2, 3, 4. Okay, it denotes that the array is 2, 3, 4. So if a query is 2 comma 6, so it denotes the array is from 2 to 6, all the elements 2, 3, 4, 5, 6. So each query gives you one array. You can say that each query is giving you one array, and you need to find how to make all of the array elements 0, and how many operations do you need for that, and you need to calculate sum this for all of these queries. So you can see for query 0, the initial array is 1 comma 2. You select these two elements and both you divide by 4. Okay, both you divide by 4, you get 0 comma 0. The minimum the operations is required is 1. Okay, so now for 2 comma 3, first you select the let's say 2 and 4. Okay, so if you divide both of them by 4, you get 0 in the first place, and for 4 you get 1, and then again you select this 3 and 1 and divide both of them by 4, you get 0 comma 0. And so now you see all of the array elements are 0, and the number of operations which you required is 2. So for the previous query you required 1, and for this query you required 2. So you require a total of 3 operations. Okay, so that is what you need to do actually. Okay, so let's see the approach. Definitely try it on your own first, and then only continue watching with the video. So you have a query. Okay, you are given q queries. Okay, and this q you are given q sets of L comma R pairs. Okay, now definitely you need to find some log of I mean this range L of R. Let's say you need to find log of L or log of R complexity, or O of 1 complexity. Okay, O of 1 complexity, to calculate this, because with that, when that gets multiplied by 1e5, then only you can calculate easily, otherwise there would be problems. So what you need to do, let's consider one query as 3 comma 5. Okay, 3 comma 5. So before that, I will tell you that first you try to see which numbers require how many number of operations. So you see, number 1, how many operations do you need to make it 0? You may need one operation, right? Because you can just divide it by 4, it will be 0. So this one requires one operations. I will write the operations here, and I will write the number here. I will try to build a pattern at first. So you require one operations. For 2, for 3, for both of these you also require one operations, because you can directly divide it by 4 and get a 0. Okay, floor of division. I hope you already know floor division. So this 4 you need to divide 2 times, so number of operations is 2, because once you divide by 4 you get 1, and then again you divide by 4, then you get 0. So you require 2 operations for this, and same for this 5, same for this 6, same for this 7. Okay, now you see for 8, if you try to calculate for 8 how many operations you need. 8 by 4 you get 2, and then again you divide by 4, you get again 0. So for 8 also you need 2 operations. So till when will you require 2 operations? You can easily see that till 13 till 15 you require 2 operations. Okay, because 15 also if you divide by 4 you will get 3 for float division, and then again you divide by 4, you get 0. But for 16 you see, you need to 1 divided by 4 to get 4, then again you get 1, then again you get 0. So for 16 onwards you get 3. So what is happening exactly here? What exactly is going to happen? So for elements 1, then you multiply it by 4. Okay, then again you multiply it by 64, you get 16. Okay, so till before 4, you can say that till before 4 it requires 1 operations, till before 16 it requires 2 operations. Similarly, if you multiply it by 4 again, 64, till before 64, that is for 63 it will require 3 operations, and so on. This is a pattern which you observe. This is the simple pattern which you observe. Now if you want to calculate something from L to R, okay, so you need L to R, okay, how many operations you need from L to R. Now I am considering that single operation is wasted in converting one element, okay, but that is not the case. I will come to that later. So for L to R, what you can do, you can first calculate 1 to L minus 1, okay, so 1 to L minus 1, how many operations you need, all the numbers, right, 1, 2, all the way till L minus 1, you just add the operations of all of them, okay. And then also what you can do is that from 1 to R you calculate, that is starting from 1 to all elements till R. Now it is very simple to think that the number of operations from L to R will be nothing but number of operations, let's say this is x, this is y, number of operations will be y minus x, because this is because what is happening, uh, I hope you understand, right, okay. So if you have the numbers, let's say consider 3 to 5, okay, 3 to 7, let's say, okay, for 3 you calculate 1 2, okay, for 7 you calculate 1 2 3 4 5 6 7, now you just subtract, so this many operations you get for 1 to 7, you just subtract them, 1 and 2, you are just remaining with 3 and 3 to 7. So I hope that is very trivial. I am not wasting time in explaining this to you, okay. So I hope you understand that. Now we are actually calculating, how is operation divide. You see, you select two integers from the array and then divide, okay, but I am not selecting two integers from this array. So let's say from I will consider a case 3 to 5, okay. So if L is 3 and R is 5, what is the array you get? The array you get is 3 4 5, okay. So what you do at first, you perform operations on these two. So you see how many operations, if you calculate individually, 3 requires how many operations? It requires 1 operation. 4 requires how many operations? It requires 2 operations, right? 4, from 4 you convert to 1 and then convert to 0. 5 required similarly 4 operations. So total number of operations you required is 5. But this is not the actual operations. In reality you can select two elements, okay. So what you can do is that for 3 4 5, let's say you can select 3 and 4, and you can perform operations on both of them and convert it into 1 0 5. Then you can select something like 1 and 5, then you get something like 0 0 1, and then you again perform operations on 0 and 1, then you get 0 0 0. So you see, you get 3 operations actually, not 5. Now how do you get this? How do you get this 3? We calculated 5, right? So it is very simple. I calculated elements, I calculated operations based on single element. So let's say you have 5 operations, so you draw 5 lines, okay. You can, what you can do is that you can just pair the operations, right? You can define this as one operation, this as one operation, this as, and the remaining pair is 1. So this is 3 operations. So in a case where let's say from a very L to R you get, let's say 15 operations, what you can do, you can just write 15 such lines and pair each of them. So you can understand that the last, in case of an odd number, the last element will get remaining, okay, and you need to do that for. So if you do 15 by 2 you get 7, right? So you just add 1 to it for odd numbers, and for even numbers you can just divide it by 2. So you can see that the general case will be for L to R, if you have a total of, let's say, x operations, x plus 1 by 2, this, where this is float division, will be the thing, this will be the total number of operations, actual operations, okay. So so what do you do, what is your flow actually? So the first thing which you do is calculate operations for 1 to L, for all the numbers from 1 to L. Now you do what? Calculate operations for 1 to R, L minus 1, okay, so this is not L, this is L minus 1, subtract let's say you get a x, you do this, x is nothing but this r minus l, okay, the 0.1 minus 0.2 minus 0.1, you just do, subtract it. So you now get x to be the operations from L to R, okay. Now the actual number of operations is actually x plus 1 by 2, because you are allowed to take two pairs and perform one operation. So the actual number of operations is nothing but x plus 1 by 2. So this is the number of operations for one query L to R, okay. So can you, how will you do it? Okay, so it's very simple. I mean, you need to now focus on something like, I have an n number, and from 1 to n I need to calculate all of those numbers, how many operations I need, okay. And this turns out to be very simple actually. This is just this pattern. This is nothing but just this simple pattern which you need to do. So let's try to write a code. You can start with 1, okay, you can start with a base of 1, you will multiply a 4 with every time, okay, and then you will try to calculate how many numbers are there between 1 and 4. So that is 3 numbers, 1 2 3. So those 3 numbers will have 1 operations each. Now for 16 also, you see 16 minus 4, okay, 16 minus 4 is nothing but 12. So you have 12 numbers in between them, and all of those 12 numbers are having 2 operations. So you just do 12 into 2. So in this way you can just easily calculate in log base 4 times, okay. I hope you understand, because every time you are multiplying by 4, so you in log base of 4 times you can just calculate it. So let's try to write a function, a different function, okay. So let's try to first do hash define ll long, okay. Just remember to do this, write a function get, okay. So what will this get do? It will take a number, okay. So let's assume that it takes x only, and what it will do is that from 1 to x, from 1 to x it will take all, it will try to calculate operations for all the numbers, okay, operations for all the numbers. So what you can do, you can have first of all one number with a current number which is 1, starts with 1, okay, and you will multiply this number with 4 every time, okay. Now what you do, let's say you also have a result, okay. So let's say you have a result with you which is initially 0, okay. So what can you do is that while you can have a while loop, while current is less than or equals to x, because the current you are multiplying by 4 every time. Now what do you need to do? You need to calculate the next element. So let's say I have the next element to be current into 4, okay. So can you blindly just multiply it by 4? Because you see you need numbers, okay. So what I want to tell you that, let's say you require numbers till 12, okay, but for 1 then you multiply by 4, you get 16, you 1 divided by 4 you get 4, then you multiply by 4 again, you get 16. Now you cannot just subtract this 16 minus 4 and say that I have 12 elements in between them, because it stops at 12. So I need, if it is exceeding by multiplying by 4, if it is exceeding my limit of x, okay, I will clip the value, I will just clip the value. So to x plus 1 I will tell that. So let's say if I clip to x plus 1, I will get all the numbers, because I am subtracting, right. So 4 minus 1 is 3, it says that 1 2 3 are the numbers. So I don't calculate the number 4, I don't calculate the number 4 exactly. So for instead of x I will just clip it to x minus 1. Do it with a few calculations, I hope you can easily understand that. So I will just do a minimum of this, okay. So minimum of current into 4, and this is what I will do. So this is my next number, okay. Now what is the count of all the numbers in between them? Next minus this current, okay. So next minus current, and at the end also remember to make the current equal to next, okay, because it will be used for the next iteration. So you see, you have this, you have the count, okay. So with what will you multiply? You need to have a multiplier, right? Multiplier which is initially nothing but 1, okay, and every time this multiplier will get incremented. So what do I need to say, or what I am trying to say for this? You see, you have initially you have 1 1 1 for all of them, then you are having 2 2 2 for all of them, then you are having 3 3 3 for all of them. So that is the thing which is getting multiplied, right? So that we need one multiplier also. So we have this multiplier, and what I can do is very simple. I can just do count into multiplier, okay, and yeah, so that's all I can do very easily. And this multiplier, after multiplying, I can just increment this, okay. For the next iteration I have just incremented this multiplier, and for this I will just simply return the result, okay. Now it's very simple and very easy to calculate everything, okay. So you just need an answer long, and what you can do simply is you just iterate through all the queries. So for, let's say, auto address of q for queries, okay. So I will directly get the vector from this, and what do I need to do is that I can add to my answer something like let's say let's calculate a count first, okay. So that will be easy. The count I calculate to be q of 1 minus q of 0 minus 1. So did you understand what I am doing is, this is nothing, q of 0 is the first element, q of 1 is the second element. So in every query you have L comma R, right? So this is nothing but q of 1, this is nothing but q of 0. So what did I tell you? For calculating all of them, you need to calculate from 1 to R first. So you need to write a get function. I have written that get function. So that get function will be q of 1 minus get of this q of 0 minus 1, L minus 1, right? And you also calculate from 1 to L minus 1 and subtract them. So that's what I am doing. I will just write the get functions here. So get of q of 1 and the get of q of 0 minus 1. So I hope you get this easily. There shouldn't be no difficulty in this, and this answer plus equal to count, and you just return answer. So but answer plus equal to count will not be there, okay. So it will be plus 1 by 2, as I had already explained you this, I think, because I am calculating, I can pair up the numbers also. So okay, so if the count is 5, so if the count is 5, you actually require how many operations? 3 operations. If the count is 6, if the count is 5, it means that answer is 3. So again, if the count is something like 6, you can pair each of them, while performing your operations, and you will get a 3 again. So it is nothing but plus 1 by 2 if you do. That is the general case for both odd and even. So this is nothing but a floor value, not floor value, ceil value also. So ceil of count by 2 is nothing but count plus 1 by 2. So yeah, that's all I guess. It should run perfectly. There should be no error in it. Let's try to run and check. So you see, you also get the accepted thing. If you try to submit it, you also should get a very decent runtime complexity, because this while loop, you have q queries, okay, you have q queries, and for every queries you are having a while loop, but this while loop is having a log of 4 time complexity. You see, log base 4, because you are multiplying it by 4 every time. So log base 4 of this L and R multiplied by Q is your total time complexity, which is quite okay, which is not at all difficult. So you see, that's all for this problem, I guess. And I hope you understood the problem. If there are still any doubts, you can definitely ask me in the comment section. I hope there would be no more doubts. If you try to do some pen and paper on your own, try to work it on your own. Don't just try to see the video and just understand, like, don't just expect that you will understand everything by just like sitting and watching and relaxing without doing some pen and paper, without doing some hands on your own, okay. So definitely try to see the whole video, and then only try to understand everything by doing pen and paper, and then only you should get it, and that is also very good practice. So yeah, that's all for this problem for today. Also, this is marked hard problem, but it is not, it is a medium easy kind of problem, you can easily say. This is not at all difficult. So yeah, that's all for this video. I hope you have a very easy day ahead. Thank you so much.